Hello and welcome to Martin Maths. We're continuing with the Maths GCSE Higher Paper 2 paper from June 2023. Have a look in the description for the link below for questions 1 to 10. We're continuing with the paper from question 11. We'll do most of the following remaining questions in this video. So starting with question 11, we have to use algebra to solve the simultaneous equation 2x plus 6y equal to 5 and 3x minus 4y equal to minus 12. So we're looking for where two lines are meeting. So to make them at the same value of x and y, I'm going to times that one by 3 and get 6x plus 18y equal to 15. This one by 2, 6x minus 8y equal to minus 24. Now I can use the elimination method and subtract that one. The x's will disappear. 18y minus 8y is going to be 10y, and 15 minus 24 is going to be 39. So then I'm going to have, sorry, that was a mistake there, minus that'll be 26y. So y will equal 39 over 26. I got my signs wrong, should have done that there as well. 18 minus 8 is 18 plus 8. So y is going to equal 1.5 because those are both multiples of 13. And now substitute that back into the first one. 2x plus 6 times 1.5 equal to 5. So 2x plus 9 equals 5. 2x will equal minus 4, x will equal minus 2. And if you want to make sure that's correct, plug it into the second equation. 3 times minus 2 minus 4 times 1.5, which is minus 6. Minus 6 is minus 12, which is what we have there. So I know that those are correct. So x is minus 2 and y is 1.5 there. Okay, a little note there. Watch your signs, because I even made a mistake there. I just knew that I'd done something wrong because once I'd done it there, I made sure I checked it there. Okay, so that's a nice 4-mark question. Question 12, the points A, B, C, and D lie in a circle, center O. A, B, C, D is a rectangle, so we know that those are right angles. AB is 8 centimeters, BC is 10. Got to work out the circumference. Circumference is pi times diameter, or 2 pi r. So if I create a triangle here, perpendicular bisector there, I know that I'll cut that in half with 4 and that in half with 5. So now I've got a right angle triangle, and I'm going to use Pythagoras. So OB squared will equal 5 squared plus 4 squared. So OB squared equals 41. So the radius, because OB is the radius, will be root 41. It's a calculator paper, so I can find out the square root of 41, and I get 6.4 to 1 decimal place, and I can then say the circumference is 2 pi r, use the answer button, 2 pi times 6.4 to shift pi the answer, and I get 40.23. 3 significant figures, so 40.2. There we go, because 3 would round down, so 40.2. Nice 4 marks there. Let's go on to question 13. ABC is a triangle, not a right angle triangle, so we need to use either sine or cosine rule. Got to calculate the angle of BAC. That's this one here. But the sine rule involves the angles that are opposite the sides. So I'm going to choose to use the sine rule to work out that one, and then 3 angles of a triangle to work out that one. So I know that 18 over sine 70 will equal 15 over sine, and I'll call it C. So that'll mean that sine C is 15 sine 70 all over 18. And you should be able to work this out all in one step in your calculator, but let's just do 15 sine 70. Divide that by 18. So I get that to be 0.78 to at least show the examiner what you're doing. And then shift sign of that answer. Answer button is really useful in the calculator exam. And I get 51, so C is 51.54. They wanted to correct to one decimal place in the final answer, but working out C wasn't the question. I then need to work out that one, because that's BAC, because the angle is always the one in the middle. Sometimes they might put a cap on that. So I know that it's 180 degrees minus 70 minus this answer here, 51.54. So I put that into a calculator, 180 minus 70 minus the answer, and I get 58.4568, 0.4568, which is, I'm going to call that angle A. So we want it to one decimal place, 58.5. Okay, that should get us the 4 marks. Didn't say we need to use the reasons, but I've used the sine rule here, and I've used 3 angles of a triangle, it's a bit of shorthand there, 3 angles of a triangle to give us angle A. Well, let's put it at BAC there. Okay, another 4 marks, so they're quite chunky, these questions here. Right, my favorite, algebra, question 14. Show that x squared minus x minus 6 over 2x squared minus 5x minus 3 can be written in this form. Skill you need to do here is to factorize. Okay, so let's factorize the numerator. X squared minus x minus 6. I know I need an x there and an x there. Factors of 6 that differ by 1 will be 3 and 2. It's negatives, they need to be different, but the greater value needs to be negative, so minus 3 and plus 2. Now I'm hoping that when I factorize the denominator, I'll have one of those factors there. So I do 2 brackets again. Now, my school teacher taught me the method first, last, middle. I know there's lots of different methods that we can use. I'm going to use this method. I split 2x squared into its factors. The last term is minus 3. Split it into its factors, but I need to know which way around because I want to end up with minus 5. So to get minus 5, probably need 6 somewhere. So to get 6, if I cross multiply, because when you expand the brackets, you multiply this term by 1 in there, not by the term within the bracket. I'm going to put the 3 there and a 1 there. So I'm going to put 6x there, 1x there, but I want it to be minus 5. So I want it to be minus 6 there, plus 1. So minus 3 and plus 1. So I should see a common factor of x minus 3 in the numerator and the denominator. So I can cancel those, and then I have it in the form that they want, ax plus b, cx plus d. So it'll be x plus 2 over 2x plus 1. And you could state, well, a is 1, b is 2, c is 2, and d is 1 as well. Okay, don't have to state that if you've written it there, as long as you have that final answer there. Nice 3 marks there. Okay, here are the first 4 terms of a quadratic sequence. So we're talking about n squared, 3, 9, 17, and 27. I always find this one really good to concentrate because you're not looking for just the linear term, you're looking for second difference. So the first difference between these ones, which will help us find the n squared, it's going up by 6, and then it's going up by 8, and it's going up by 10. So now I need to find a second difference to see, now that I see this, the second difference is the same, means I'm dealing with an n squared, but I take half of that 2 to be the coefficient of n squared, so it happens to be 1. Half of 2 is 1, so that's fine. So I look at my terms, 1, 2, 3, 4. If I square them using my square numbers, I now look at what am I different from there to there. Well, I need to add 2, I need to add 5, I need to add 8, I need to add 11. And here I look again for another difference. This is the linear difference now. I'm going up by 3 each time. And that's where I get n squared plus 3n. But if I plug n squared plus 3n into here, I'm going to have 1 plus 3, which will be 4. 4 plus 12. Sorry, 4 plus 6 is 10. And then 9 plus 9 is 18. It's not exactly that term unless I subtract 1, which means my sequence is n squared plus 3n minus 1. So keep having to find the term, square it, check the difference, and then check the difference again. N squared plus 3n minus 1. So quite a lot in there. Histogram question here. I'm going to skip that. Solutions are available elsewhere. I'm going to go to, again, my favorite, the algebra. Iteration here. We have x to the 4 minus x squared minus 5 equal to 0. Need to show this can be written in this form. Right, so I'm taking the fourth root. There's x to the 4 there, meaning when I rearrange this equation, I remove everything that's not x to the 4 to the side, minus x squared there, so I'm adding x squared on both sides, minus 5 there, so I'm adding 5 there, looking right, and then I take the fourth root. And this is a very useful method to find a solution. Those of you who take maths further will see these numerical methods again. So now I have shown that. It's just 1 mark, but I have shown that. So I'm going to start with the first number being 1.5, and using this formula as the iteration, n plus 1 is equal to the fourth root of x to the n squared plus 5. So x to the 1 is the fourth root of 1.5 squared, that's x to the 0, plus 5. So I'm going to put that into the calculator. So my calculator hopefully has got that button, yeah. So the fourth root of 1.5 squared plus 5. So x to the 1 is 1.64. So now x2 will equal the fourth root of 1.64 squared plus 5. And if I set this up correctly, with my calculator, it should be able to do all of that. So the answer squared plus 5. So I can now, because I've got that answer button again, very useful, the memory of the calculator, and newer versions of these calculators will probably have better memory as well. I can get 1.66, so 1.665, x3 is equal to 1.669. It tells us to keep going 3 times. I've done it 1, 2, 3. Let's do it a fourth. 1.67. But we can see it's converging anyway. If I kept going, my answer would remain 1.67. So if I want to get it to a certain decimal place, the fact that it's converging, it won't matter how many times I've done it, as long as you can see the pattern. So I'm going to put 1.67 to get us those marks. But if they wanted a very specific one, then I would go back and say, enter this one here, 1, 2, 3, and get that exact answer. Okay, right. Question 18 is a ratio question. I'm going to skip that one for today, just seeing the time. Don't want to make the video too long, and I do want to get to a couple of other questions. Right, ABC is a right-angled triangle, 9.3, 12.6. But these are estimates because they're rounded to the nearest millimeter. So calculate the lower bound. So the lower bound for 9.3 will be 9.25. Its upper bound is 9.35. The lower bound for 12.67, so 12.6 is 12.55, and the upper bound is 12.65. But now they want to say calculate the lower bound for x. So to make this as small as possible, we want that angle to be kind of like that, not big. So we want this to be as small as possible and this is big. So I want the lower bound of that and the upper bound of that. So I want that and that. So I want sine of x equal to 9.25 over 12.65. So I can do that on my calculator. I can do shift sine of 9.25 divided by 12.65, and I get 46.989. 989 as x there. Now they've told us to show all the working, so I can leave that as 46.989 there as my final answer. And if you wanted to check that that is the smallest, well, try the other combinations of the upper bound and lower bound, and you'll see that you want the O over H, the numerator, to be as small as possible. Okay, question 20 is a vectors question. OT is A and RT is B in this direction, in that direction. So we're going to find MT, where M is the point on OR such that OM to MR is in the ratio 2 to 3. And they want MT, so they want going from there to there. And always try and imagine this like a map. I'm going from this point to there. What street can I go on? Well, let's firstly work out what OM is. OM is 2/5, because there's 5 parts there. Remember, it's not 2/3, it's not a fraction, it's a ratio. So 2 plus 3 is 5 parts. Okay. So it's 2/5 of OR, which is 2/5 of. Now, how do I go from OR? Well, I have to go along A and negative B, so it's A minus B. So OM is 2/5 of this route, right? So MO is the negative of that, negative 2/5, A minus B. So if I want to go from M to T, I want to go minus 2/5 A minus B plus A. And they tell us, sorry, didn't show that, minus 2/5 A minus B plus A. And they want to give it answer in its simplest form. So I've got a minus 2/5 A plus A will be 3/5 A, and then plus 2/5 B. So it's just, you could work that out differently. You could have gone M to R, and that way will give you the same answer. Again, like a map, you're trying to think, well, like, I haven't built the road there, so I've got to go there, and then I've got to go here and here. Okay, a nice 4-mark question. Here is the graph of y equals f of x. So this is f of x. And on the grid below, we want to draw the graph of y equal to f of x minus 4. So when it's f of x plus or minus a, it's always a shift in the y direction. So f of x minus 4 is going to move each of these points down by 4. So the origin is going to move to here. Okay. And all the other ones are going to move as well. So that point there, which is minus 1, 1, is going to move to minus 3, 1. I don't know why they couldn't just do it on the same graph. Minus 3, 1. This point here, which is minus 2, 1 is going to move to minus 2 to minus 3 to there. And then this point here, which is minus 3, 0, is going to move to minus 3, minus 4, like that. So that it's moved down there. So that is f of x minus 4. Okay, again, would have been easier just to do it there. And here again, on the grid below, draw the graph of y equal to f of minus x. So when x changes to negative x, you're reflecting in the y-axis. So it was here. It's now moving. Sorry, Sorry, I've moved it too far that way. So I'll move it just to there, there, and there. So the points are 0, 0, 1, 1, 2, 1, and 3, 0. Just go back and correct this. I made it wider than it was. Again, that's why I prefer to have been on the same graph. So it should have been minus 2, 3, which is there, and then minus 3, minus 4, like that. That's the correct one. Okay, just straight down by 4 there. Okay, and for today's video, we're gonna stop there. There were 2 or 3 more questions up to question 24 on this paper, which would have taken us up to a total of 80 marks. So that's over 20 minutes. Thanks for watching. Don't forget to like, subscribe, and share, and good luck with your maths.